9th standard science lesson physics lesson చూద్దాం motion lesson.
Hello everyone, hello. Let's go. Why is it so thick? 1 minute. Okay, so we'll just be starting the class in just a minute. Okay, so hello everyone, welcome back. Hello. Hi, sure. Fine. Everybody in the chat, just I'll give you a poll. I have 2 polls already. We're doing grade 9th motion. Hello everyone, hello, sure. Let's start off. So what is motion? I'll end this poll. Alright, motion is defined as when an object starts moving due to either energy generated in it and or an external force applied on it. By force, like by force you define it as a push or a pull. Oh, you're in 10th. I believe you're preparing for your boards right now, or your boards might have ended. Force applied on it. The force applied on it. You know what is a force? Like basically a push or a pull applied on the object, which causes a change in the speed and direction of the object. It could be or, because any change in the speed, or maybe any change in direction, or any both, because direction cannot be defined, but you can use it to define as it's the state of motion. So this is referred to as motion. Alright, now I'll give you another I'll tell you in a minute. I gave you a second poll. Okay, so is motion relative? How many people have voted? Out of all, okay, we have 100%. Fine. After this, whenever I ask questions, I'll be giving you polls. You guys will be doing it like whenever I ask a question. Alright. Which causes a change in the speed or direction of the object. Let's say this is a box, a heavy box. Then let's say this is you. You push. Okay, a really realistic drawing of a stick man here, but whatever. You push it, you notice that the object starts moving. Remember when you are in your 8th grade, alright? So you learned about this chapter called, yes, I'm in 9th, force and pressure, alright? It showed that a force, we learned about the different effects of force. What are the different effects of force? Force changes like the position of a stationary object, and it also helps stops or changes the speed of the moving object and all. So therefore you can apply that here. Alright, so this, you move it, you notice that you are applying force on it, so it's moving and it's motion. Then I asked you a question called, is motion relative? Alright, what is the meaning of relative motion? Alright, so let's say you're inside a bus or a train. I'll just take a train, it's easier to draw. A bus is also easy. So this is you, alright? Let's say you have your brother sitting next to you. To you, your brother would be in rest. You would be in rest to each other's perspective. But let's say you're looking at a tree or a person standing outside, or your friend waving to you. You notice that he is like, you're going here. It appears as if your friend is moving. You won't feel like you're moving, but it appears as if your friend is moving. Similarly, that's the same for your friend. He doesn't feel like he's moving. He feels the train is moving, which is true, of course. So that is what is the meaning of relative motion. So to a person who's sitting inside an object that's moving, all the objects that are outside at rest appear as if they're moving to the person. However, the person who's standing outside would see the person inside the moving object as moving. Alright? Now, I use this word speed. I know no one will get confused by this, but just in case, hello. Of course, I spoke with you before. Speed. What is speed? speed is basically the rate of distance within a given unit of time. Alright, so I'll give you another poll now just to encourage. Alright, end this poll. Alright, now another poll. I want everybody to vote this. Alright. Okay, just a minute, guys. I gave you funny options. Okay, so you have a poll. Alright. Okay, fine. Let me just continue. So let me wait for you guys. I'll just wait for maybe 20, maybe. Okay, fine. I'll give you 15 seconds. Okay, fine. Let me be generous. I'll give you 20 seconds. 20 or 25. Alright. Fine. So guys, there's a poll in the chat. You guys can answer it. So I'll read the question out. How is speed related to distance? Speed is distance divided by mass. Speed is gravity but upwards. Speed is distance divided by time. It has really funny options which you just put in, which makes it easy for you all. Okay? Alright, I'll wait for another 10 seconds. Alright, your time's up. We haven't had any vote right now. Anybody please vote from that. There's a poll running in the chat. Okay, anyone in the chat hit the poll. Alright. I'll end the poll now. There's no votes. Alright, next one. So, speed speed is equals to distance by time. So later in 7th grade you learned about the distance time graph, where this is the slope, you have the distance here, the time here. The speed will be the distance divided by the respective time. So that is much easier. Now, first, let me define each of the terms in this formula. Speed, distance. To be fair, I'll just make this simple for you using simpler terms rather than going much more deep. Distance is basically, no, okay. Let me take an example. Let me take an example of a car, a toy car. Alright, this is a car. It's moving on this road, small like a table or something. It's going forward, then it stops over this point. Sure, the distance covered by this car when it started from here and ended over here, let's say I'll label it A, B. The distance covered by the car is AB. The length. The length is basically the distance covered by the car. So like when an object moves, the total amount of distance that it covers along the path on which it moves is called the distance. Alright? Now, speed I already defined you. It is the rate like speed distance per a given period of time, whether it should be kilometers or whether it should be an hour or a second, an hour or a second or a minute if you wanna take that as an example. Alright, now we finished all of this. Time is basically the amount of time taken by the given body or the particle to cover the given distance. In this case, hello, hi Mohit. I mean, of course I spoke to you. So AB is basically the distance, right? By the speed gives the time. Let's see. Let D represent distance, capital S represents speed, and T represents time. I'm a boy. Now, so D by T is equals to S, right? Distance by time is equals to hi, hello. So this. So the distance by time is equal to speed. So you remember about linear equations, right? When you're in your 8th grade, you have learned about linear equations in one variable, where you can do transposition. What is transposition? Changing the order changing the operation that you're performing on it, like to its opposite operation, like addition becomes multiplication, addition becomes subtraction. Oops, I was in some world. Addition becomes subtraction, then multiplication becomes division, then yeah, pretty much exponentation maybe becomes root. Now, so D by T equals to S. So you can basically say that when you have the speed and the time, the distance is the speed times the time. Alright, so then again you can flip this formula, saying that distance by speed is equals to the time, of course. Alright, so then you flip the formula, you can get the time. Alright, so we have finished speed. Now the SI unit of speed is meter per second, because see, for distance it's meter, for time it's second. So it's supposed to be meter by second, which is equals to meter per second. Alright, simple, easy, got it. Just anybody did not understand anything, you can okay, is everything clear? Is everything clear? Just I gave you a poll, you can put it in there. Alright. I'll just wait for another 10 seconds and I'll continue. Is that alright? Yes. Yes. You can ask any doubts in the chat. You can flood the chat with emojis or whatever. And try and answer the questions which I asked. Alright? 31 people are okay? Sure. Now, let's move on to the next one, which is displacement. Alright? What is displacement? Basically, now, let's say you're traveling in a circular path, okay? You start from A, you go on, and it is here. So, let's say if you have another topper beside you, and you're racing with them, what path would you take? First, let us calculate the distance here. So, what is the circumference of a circle? Alright, everybody knows the circumference of the circle, right? You have studied it before, you have studied it in your 7th grade. It's, for your reference, it's 2 pi r. Alright, 2 pi r is the circumference of the circle. Now, what is the circumference of a semicircle? It's pi r plus 2r, but we won't be using this 2r here because we're only calculating the circumference. We're not going to add the diameter. Alright, so just remove this. Or another easy way to remember this is just divided by 2, you get pi r, which everybody uses. So, pi r. Now, the distance would be pi r. Okay? Fine, everybody got it? Now, you have another top. Let's say your name is, I'll put your name as Q. Then you have P next to you, who is a topper. He takes the shortest route. So what is the shortest route? The shortest route is, instead of covering this, you just cover the diameter. No, wait, till here. Oops, the point is here, okay? It's straight. It's the diameter, alright? So I'll just draw it, okay? What is the diameter? 2r. Fine. 2r is the diameter. So, the shortest distance to reach from point A to point B is, what is it? 2r. Fine. Now, this shortest distance is what is known as displacement. Is the displacement. Fine. Alright. So, now before we understand what is the difference between this distance and displacement and how do you calculate displacement easily. First, you're supposed to know what are the two types of quantities. I'm not talking about the physical and derived quantities. I mean, you can use them to refer, but then they're not the same. So, see, when you talk about motion, force, and all, you have two types: scalar quantity and vector. Fine. So, what is a scalar quantity? A scalar quantity is a quantity that has no direction. So like it does not need a direction to be specified. I mean, example, you have distance, speed. No, a vector quantity. No. Okay. Remember that again. Let's go back to 8th grade. So remember when you are thinking about net force and all, you're supposed to know the direction, right, to calculate the net force. I mean, when it's on the same direction, like it's pointing in the same direction, you let's say this is F1, this is F2, you add up F1 plus F2. However, let's say it's acting like this in the opposite directions. It's supposed to be F1 minus F2 slash F2 minus F1. This should be when F1 is greater than F2. This should be when F2 is greater than F1. Alright? I can just represent them by the length of the arrows and then find out which is greater and then not write all of this. But then just for no confusion, I'm just doing this. Alright? Everyone got it? More. Contribute through super chats, guys, so that we can make some more videos for you. Alright, okay. So yes, let us just continue. Now, so like now, those such types of forces which need a direction and a magnitude to specify them are called as vector quantities. Those quantities which require both direction and magnitude are called vector quantities. Now, let's say you have some examples of velocity. Don't get worried. I'm just talking about it. Velocity, not velocity, and then you have displacement, acceleration. Okay, because for acceleration and velocity, and they are derived quantities. All right. Okay. Now, differences are displacement is basically distance. First we'll do with distance, then displacement. See, distance does not need a direction, i.e. it's a scalar quantity. It only needs length, while displacement needs both magnitude and direction. Alright? Then the second one is displacement depends upon the path. I'm saying displacement, alright? Fine. I'm used to it. Displacement depends upon the path of the route. Like, let's say, now, to explain this, I'll show you this. Fine. Normally, I'll show you this right angle triangle. Fine. Okay. So, let's name the side A, B, C. Fine. Now, here, you notice if let's say you're going from here to here, the distance is equal to A plus B. That's easy, right? Everybody knows that. You can say that. Now, if I say displacement is also equals to A plus B, will it be correct? Everyone will be correct if I say the displacement is also equals to A plus B? If I say the displacement is equals to A plus B, will it be correct? Okay. Huh? Okay, will it be correct? No, right? I mean, I just told the answer, I mean, because. No. Why? Why? Why is it not correct? I mean, displacement, distance is A plus B, displacement is also A plus B. No. Wrong. Is wrong. Okay, it's wrong. Why? Because what do we study about displacement? Huh? Shortest distance. No? Now, the shortest distance here is C. Now, you might also have another question saying that isn't it supposed to be that the sum of the two sides? How is it like the hypotenuse shorter than those two? Remember, now max comes in. Alright, max. See, remember when you are in 7th grade, you study about this thing called triangle inequality theorem. It says that this, let's say I have A, B, C. It says that A plus B should be greater than C. Fine. B plus C should be greater than A. A plus C should be greater than B. The sum of any two sides of any triangle that you construct should be greater than the other or the third side. Alright? So remember that. Sometimes they may also be they will also try to trick you saying that 3, 4, 7 and they'll trick you and saying that see, now here 7 plus 4 is 11. Fine, okay. 4 plus 3 is 7. 11, okay, 7 plus 4, 11 greater than 3. See, 7 is equal to 7. This is wrong. You're not supposed to have it anything equal to or even less than. Okay, guys? Got it? Okay? Good. Let's continue. Now, continuing. Fine. Now going back to the displacement. So in this case, you have A, B, C. Here C would be the displacement from here to here. I'll just name the triangle as well. AB is the displacement. AC plus CB is the distance. Simple. Now, distance does not depend upon the path. And the next one, which is related to the previous point we discussed about the path, is displacement could be either positive, negative, or zero, and it could also sometimes equal the distance. Let's say, see, anytime when an object is moving in a straight line, both its displacement and its distance is the same thing. Alright, fine. As long as it does not change its direction, distance and displacement are twins. When it changes its direction, they both become rivalries. Remember it, fine? Remember it like that. Okay? Fine. Fine. Now let us go on with the next one. Okay? So we have done a lot. We've done all the points. Now let's move on to velocity. What even is velocity in the first place? Velocity is basically the same thing as speed when you don't care about the direction, which in what means I'm saying that when the object is moving on a straight line, is the same as speed. See, I told you the displacement. Alright, displacement is equals to distance when the object is moving on a straight line and does not change its direction. In that case, if it is a uniform motion, i.e. it covers equal amounts of distances in equal intervals of time, then velocity is equal to the speed as well. Fine? So, velocity and displacement, distance and speed. Fine. Okay? Velocity, I'll represent this with a small s. Fine, velocity is equals to, I'll represent v. V is equals to displacement represented with a smaller s, speed and distance replaced with a bigger capital S by t. Okay, v is equals to s by t. This is the formula. V is the velocity, s is the displacement, and t is the time. Now, let's say the car is going at some around 100 kilometer per hour. Suddenly, when it's going on a straight line, let's say you're on a highway and it's straight for around, let's say, 40 to 50 kilometers, you notice that the distance and the displacement would be the same. The distance would be 100 into 50, which, no way, what? 100 kmph. And sorry, that's the distance. Oops. 950 by 100, you get 1 by 2 hour or 30 minutes if you travel at a constant speed of 100 kilometer per hour / velocity when it's in a straight line. Now, no. Let's say, okay, you're the driver, let's say it's your father or your uncle, forgot his phone at his house. So he had to take some U-turn or just reverse, okay, something. He'll take a U-turn, he'll stop, no? And the direction changes. Now it's this side, now it's this side. As soon as the direction changes, the velocity as well changes. Just remember that. Straight line, velocity, displacement, velocity and speed and distance and displacement are good friends. However, as soon as you change, they suddenly turn into rivalries. Simple. Okay? Fine. It's like your pen. Let's say when you're writing with your pen and the surface is smooth, the pen is happy, it will do its job, the ink will flow smoothly. As soon as you switch over to a rough surface, the pen becomes a rivalry. Simple? Easy? Got it? Okay? Let's continue. Now, we have finished this with, no we didn't, no, let's look at average velocity. It's just velocity average, okay? Don't worry, just don't get confused. This is average velocity. What is average velocity? Now, what is average speed? I forgot to discuss about this. Average speed is basically total distance traveled by total time taken. So let's say your distance, like let's say you can travel 50 and then 20, then you have 3 hours and 2 hours, 3 hours 50 kilometers, 2 hours 20 kilometers, 3 plus 2, 75, you get 14 kmph. Okay, fine. Alright, similarly, now when you have average velocity, it is, okay, see, first let me just show some how to represent the terminologies. Initial velocity will be represented by u, then final velocity, okay, will be represented by v. So average velocity is equals to v plus u by 2, which is the initial velocity plus the final velocity by 2. Okay, now we finish velocity. Let's move to not this, acceleration. Now, what is acceleration? Just a minute. Okay, fine, let's just continue with acceleration. So, let's take the same example, a car going at 100 kmph. Now, it's going on a straight line, okay, we'll take it as a straight line now. Fine. Although even though it's a curve, the acceleration could be easily found if the velocity is listed, unless we move on to the equations of motion, which we'll do after this later. Now, acceleration. What is acceleration? Simple. Fine. Now, I have 100 km per hour. A car is going at 100 km per hour. It's the initial velocity listed in the question as u. Fine. Now let me tell you a better way to calculate displacement. Just a small thing. Displacement is equals to I said I'll represent it by capital S. The final position minus the initial position. I'll write this as final minus S initial. Okay. Fine, got it. Okay. Alright. Now let's go back. See, so the car is going at 100 kmph, fine. A kilometer per hour, fine. Now suddenly there is a small barrier in front. Okay, like around maybe. Well, you don't need this first of all to calculate acceleration, but then just to know it, fine. It's located about maybe, okay, fine. The barrier is 800 meters away, fine. In our Google Maps, it shows that barrier signal, even though I don't know if it shows it. It shows any collision signal, but I don't know about the barrier. So, you apply a brake. Fine, you apply brakes. The car slows down to 100 to 0. Let's say it slows down to 0 itself, even though it might get to slower. Fine, let's just take, okay, for instance, we'll take 100 km per hour to 20 km per hour. Now, what is the acceleration or the amount of speed decreased? Fine. Here, what I am taking is that acceleration can be negative. Remember that. Fine. And acceleration can also be 0. And displacement can be 0. Like when, let's say you start from here, you come back to the same point. The df minus di, the final position minus initial position will be 0. So the displacement is 0. Similarly, acceleration can also be 0 or negative. Here, let's see the circumstances where it's negative 0 and positive 0. We'll discuss when we do graphs. I mean, 0 is just basically when the velocity remains same, but fine. Now, when do we have a situation where it is positive? Let's say the final position, okay, v is velocity, the final velocity is greater than the initial velocity. Fine. Second circumstance, negative, when the initial velocity is greater than the final velocity. Okay. Third circumstance, when it's 0, velocity is always the same, never changes, / uniform velocity. Those are the 3 circumstances. Here acceleration is 0, here acceleration is 0, here negative, here positive. Now, looking at this, all of you tell me, will the acceleration be positive or negative? in this circumstance, will it be positive or negative? Okay. I'll end the poll in around 10 seconds because it's a easy answer. Fine. Okay, see. 120. This is, I'll give you a hint. This is the initial velocity, this is the final velocity. U, V. Fine. That's easy enough to determine whether it is positive or negative. That information is enough. Which one? Okay, so your time is up. So the answer is, it'll be negative. Why? See, okay, fine. Let me just discuss the formula for acceleration. Acceleration A is equals to change in velocity by change in time. So A is equals to final velocity minus initial velocity. Final velocity minus initial velocity by time. And now if they give two times, you just find the change in time and then divide it and all. Okay, so acceleration equals to delta V by delta T. Alright. Now, in the case where we have the initial velocity is 100 and 20 is the final velocity. Now, what is the formula? A equals to delta V by delta T slash A is equals to V minus U by T, no? So, final equals to 20 minus 100 by time, what was the time? It was 5 seconds or something. I didn't mention. Wow. 5 seconds. No, 5 seconds is too bad. I am going to find it in kilometers. Okay. It took him. Okay, how do you say this in hours? Okay, let me just say it took him 1 by 10th of an hour to solve. So it is just going to be 20 by 100 by. See, it's easy to change units, but then no, I just don't want to do. No, but okay. So A is equals to 20 minus 100 by 1 by 10 of an hour. So A equals to minus 80 by 1 by 10. Alright. So then, so A is equals to what did what? Minus 800 SI unit of acceleration meter per second. Oh my god, why is it not in meters? every problem hassle minus 8, and okay, this is kilometer per hour, I know that. Okay, and kilometer per hour, okay, by hour equals to, yeah, kilometer per hour. Oh my god, changing, believe me, changing units is something that I hate, but it's easy though. I mean, you just do 5 by 18 for kmph to meter per second, then 18 by 5 for the opposite. Alright, so minus 800 kmph, kilometer per hour square. Okay, wow, still can't believe this. Minus 800 kilometer per hour square. Oh, I'll leave it now. Let's not talk about this. I just gave something. Alright, now after we finish the really great round of acceleration, alright, just drawing circles now. Okay, now I hope everybody got a brief overview on acceleration. Okay, now after this, what are we supposed to do? Our equations of motion. Fine. See, pretty easy to remember this. It's pretty easy to remember this if you like just look at it. V is equals to U plus AT. S is equals to UT plus half AT square. Then V square, sorry, 2AS, okay, whatever. V square is equals to U square plus 2AS square. You can do this as well sometimes. And then this is the same thing as this, okay? Just brought by doing the minus or the okay? Alright, now, equations of motion, I'll give you a question now. Fine, just try it now. Like, you just need to apply the equation, substitute the values, find out the answer. Simple. Okay, yeah. Okay, I'll give you the most basic one. First, a car is moving with a car started from rest and is moving with a constant acceleration of, okay, now what, acceleration of 3 meter per second square with time equal to 4 seconds. Alright, okay, now here I gave you the initial velocity, which is 0. We gave you the acceleration constant, which is 3 meter per second square. We gave you the time, which is 4 seconds. I'll give you this question in the poll. Do it if anyone is there to do it. And then, okay, a car answer the following question and choose the correct answer. Okay. Now 1 minute, guys. I'll just pause this. Okay, so a poll has started. Find out the final velocity and give me the answer. Alright? Okay? So, yes, you can start. Does anybody do the question? Please solve the question and give me the answer. Okay, so we have it. So okay, I'll solve the question right now. Just observe carefully, as this is a really important question, and these type of questions will come in exams. So the equation you can use here is v equals to u plus at. Fine, okay. V equals to u plus at, where velocity u is initial, v is final velocity, u is initial velocity, a is acceleration, t is time. Okay, guys. Fine. So v is equals to u plus at. U is what is u is given as rest now, so it's 0. V equals to u 0 plus acceleration is 3. So just you have to multiply this, then time is so 3 into 4. Now v equals to 0 plus 12. Fine. Okay. V is equals to 12 meter per second. Always are the unit. Simple, no? The answer is B. Okay. Fine, understood everyone? Okay, now the next one. Fine, I'll end this poll. Now, there are free fall questions as well, where you have to use this. Okay, what is acceleration? A is equals to v minus u by t, all that. Fine. Now again, you don't need to list this out just to test this. Fine. Now, equations of motion are v equals to u plus at. Okay. S is equals to ut plus half at square. Then, what? v square minus u square is equals to 2a. Yes. You can use the other form of this as well. No, nothing. There's no change. Fine. So, what is FIFA? Let's say you throw a ball up. You wanna see like how it like it's gonna fall down on that. So now for this you need to use gravity, acceleration due to gravity. Here the gravitational constant we need to use something called as the acceleration due to gravity, which is 9.8 meter per second square, which can be expressed as 10 meter per second square. You don't use this, you only use this the rounded form of it because it's much better. Now I'll give you one free fall question with all the details. First one, a body, basically just replace this g, which is the acceleration, with all of this. So this becomes g, this also becomes g, this also becomes g. Yeah, see. Now so a body is thrown upwards, a ball, okay, thrown upwards, alright, then okay, fine, okay, what do I do now? Let me think. Okay, see. Yes, I do. Hello. Okay, so body is thrown upwards at okay, what do I say? At velocity of 12 meter per second. Acceleration is equals to 10 meter per second square, of course, the g constant, sorry, gravity. Then what else should we give? Time equals to 4 seconds. Find the height, or like what height it reaches. See, another hint, you use the equation v square minus u square. You have the initial velocity as 12. You have to find you can find, you first maybe use v equals to u plus at, because you have the time and the initial velocity and acceleration as well. After you find this velocity, use the last equation, which is v square minus u square is equals to what? V square minus u square is equal to this. I'll just give you a poll right now on this question. Fine. Fine, I'll stop sharing just for a minute. Okay, I'll pause the Guys, there's been a small mistake in framing the question. The question is basically, remember this, a body is thrown upwards with an acceleration of g is equals to 10 meter per second square and time is equals to 4 seconds, and of course you should know that the final velocity will be 0. Now the second thing is that just remember this. Alright, I'm gonna tell you this. Now an object is moving upwards, gravity is acting downwards. Fine. Sure, I'll go on with the videos. It'll be negative. However, downwards gravity sometimes acts upwards, it's positive. Fine. Alright. Okay. So I told you, right? Fine. Understood. If it's going upwards, it should be like, let's say if an object is going upwards, the gravity will act downwards, so it's negative. However, when it's going downwards, even the gravity is acting downwards, right? So like when both actions, remember net force, both of them, let's say if F1 g, the speed will be F1 plus g. So see, it increases the speed, so it's supposed to be positive, right? On the other hand, the other one decreases the speed. Okay? So just, alright, reply this answer in the comments. Now the last thing or the last topic we have is uniform circular motion. Fine. What is uniform circular motion? Simple. Let's say you have a stone and you like rotate it and like that. See, now, like remember the case that we took before, the cycling your rate Swiss. So similarly, distance is of course, speed is of course 2 pi r by 2, because 2 pi r is the distance by 2. Simple. Because 2 pi r, what is 2 pi r? Circumference of the circle. Now similarly, what is the velocity? Velocity is displacement by time. What is the displacement of a circle? It should be the diameter of the circle, which is 2r by 2. Simple. Alright, so I believe that we have reached the end of the stream. Thank you all for watching, and I'll see you next time in the next video, guys. I'll make some other live videos today. Fine. Thank you guys for watching, and I'll see you next time in the next video. Bye bye. Bye.